Hello again. We're going to take a look at Lab 11D, Snell's Law Lab. This one is a bit similar to 11A in that it uses a lot of the same materials, same sort of techniques. So once again, I've got my cardboard. This time, what I've done is on the center of it, trace out my acrylic block. Now, some of you have different shapes of acrylic blocks. Because I sent them home, we kind of got whatever I had, and so mine, you notice, isn't even transparent, so I kind of have to go along with that. This will just fill in for it. So I've traced that outline on the on my paper here. I'm going to set my block carefully in within those lines, and I'm going to set up a line. So I'm putting one pin in pretty close to my block, and then I'm going to take another pin, and this time we're not aiming for any specific point, so it's just putting it in a line, but I don't want it a perpendicular line. I want it at an angle. In this lab, you're going to make these first lines at 3 different angles, sort of compared to the normal line: small, medium, large, and we're going to see what it is. It is possible to get too large, and you'll kind of know it when you see it because you won't be able to line it up on the other side. So now those two are in a line. I'm going to turn this around and peer through my acrylic block. So get your head real low to the ground. You're looking through, and you want to find the spot where you can see those pins in a line. So essentially you only really see the closest pin that you put in. And I'm going to put a pin on the opposite side right there. And then I'm going to take my second pin and block the view of all of them so that all 4 of those appear to be in one straight line. Okay, then you can set your block aside. You're going to draw those lines, so you can take your pins out and just use the holes again. So here's my exit line. We call that the refracted line, or refracted ray. I'm going to take my first 2 pins out, draw the line through them. That is called my incident ray. And then I'm going to connect the 2 inside where the block was. And I think maybe I have that called the internal. Yeah, I'm not sure I even name it. That's okay. And now, so it looks like this. And then I'm going to make a measurement of all of those. So right where the incident ray goes and hits the block, I'm going to make a normal line, and I'll make this inside the block and outside the block. Then I'm going to do the exact same thing for the refracted ray, and the exit, I guess, is what I've called it in the lab. Change that to be consistent. So it'll look like so. And then we want to measure all of those angles. Our incident angle, our refracted angle, our next refracted angle right here. All of these are measured from the rays to the normal lines. And then finally our exit angle. And notice that with these 2, since these lines are parallel, these should be opposite interior angles, and those should be the same. And then you're going, so I only have one part of the table where that's measured. Okay, and then you are going, there's some math involved with there just to look at a couple different ratios, kind of leading you towards the answer. But the mechanism of actually doing it's pretty simple. If you want to get a clean piece of paper to do another one, that's fine, but I want you to do 3 of them. With varying angles. So maybe you start with a low angle and you go towards high. There will be a point where you can see here that if you choose too large of an angle or put it too close to this side, that it'll exit out the side. We don't want that. We need it exiting out the opposite parallel side of your block. But any angle that is small enough with positioning over here to do that is great. And that's all.